Hi guys, how's it going? Welcome to our second tutorial. I am Nikhil. In the first tutorial, we saw the journey that the hello-world.c took to reach hello-world.exe. It went through these steps of pre-processing, of compilation, of assembly, and finally you link to get an executable. In this class, we are going to go over something called as a library. So we saw that we saw a printf statement, but we haven't seen a definition. So how did it get the printf definition? So it got from the standard C library, which I'm going to be explaining it to you. So before I explain anything, you need to understand what a library is. So library is basically it's a group of .o files put together in a single file. So these are called as object files. So you compile them into object files and you put them into a single file, then you have yourself a library. What is the benefit of doing it? So if you have like say 100 object files, you need to keep linking them during execution, which you don't want to do. So you want to create a library and just the developer can just access that library and get those functions in. So for example, we saw a printf statement. There are 10 printf statements, fprintf and many other things, and they are put together into a single library, into a standard library. So there are two types of libraries. One is called a static library and one is called as a dynamic library. I will go in detail about these two in further classes, but if I mentioned it, let me explain on a brief what it means. So static libraries are those libraries which is linked with and they become a part of the application. So it is present in the exe file. It is present in the executable file. Dynamic library on the other hand is something which is linked at the runtime, but it knows where the library is present. So it becomes they're not included in the executable component, but they are typed during execution, which means they are used during execution, but they are not a part of executable component. So we will go in more detail in further classes, but this is what you need to understand. In this session, in this class, I'm going to show you how to create a static library and use it. So you will get a fair idea about what a library is. So the header file of test1.c is test1.h and test2.c is test2.h. So I will show you what test1.c consists of. It's a pretty simple function which is going to be setting the value of 5 to 5. That's all it does. You can call this also a setup function, and its header file contain declaration. So you can include this header file into another program, for example main.c, and make the compiler aware of the declaration for this function. Similarly, you have test2.c, which sets the value to 100. So the test1 function sets it to 5 and test2 function sets it to 100. Similarly, the test2.h header file declares this function. So the compiler is aware of the declaration. Now we will see what our main program looks like. We have included stdio.h so that you can print the printf statement. You are including test1.h, okay, you can use the test1 function. You are including test2.h, so you can use the test2 function. Now, if you compile the main program, it's going to throw an error showing undefined reference. So it was not able to link the function, but it is complaining that I know the declaration, but where is the reference? Where do I get test1.c? I allocated a slot for test1 and test2, but they are not showing me where the definition is. So I'm going to exit the program. But how did it find for printf? That is because the GCC gets a default library called as glib library, which contains all these printf statements and all the standard input output functions and everything by default, and it links it automatically without you knowing it, and hence it did not throw an error for printf. So what we need to do is we need to do the same thing. We need to make GCC aware of a library. We need to create a library for test1 and test2, and we need to link it to main.c so that it can use our functions of test1 and test2. So in order to create a library, we need to create object files. As I have told you before, a library is a collection of object files into a which is put together into a single file. So let us create a let us create an object file. So how do we do that? We use GCC and we give two files. The minus C will indicate will tell the genome compiler to stop at assembly. After you are done with assembly, then you will get your object code. Do not give that object code to the linker. You get two object files, test1.o and test2.o. We need to put this into a single file. How do we do that? We use a tool called as archive, which I'll show you a man page of archive. So what we do, what archive does is it creates and modifies and extracts from archives. An archive is a single file holding a collection of other files in a structure. So in our case, it is a single file which is the library, and it is a collection of other files. And now we are going to use this archive tool to create a library called as lib-test.archive, and it is going to be taking the object files as input. It has added it. So in order to see what your library contains, use minus the option on your library, and you will see what are the libraries, what are the object files present in that library. Once you are done with this, you need to link your library. So you have successfully created your library. Now you need to link this library to your main program. So we use again GCC, and I don't want the output to be laid out. I'm going to make it. And what is the file is main.c. It and give the path. The path is the current path of this one, and use minus L option to give the library name. So the library name is called as is test. So we give test, and this minus L option is going to replace that with libtest.a, and there you have it. So you have created an executable, and when you run it, now you see your value being set to 5 and then being set to 100. So what you can do is just pass your libraries around, and you can make other applications using a setter function, and you need to just include your header files and make sure that the linker knows where your library is. You can also put it into the default path where the G library is. So I can also show you the standard libraries are present here in the lib, and I can do AR minus T on libc.a, and I can grep for stdio. So you have stdio.o function which is an object code for printf statements and other statements, which the GCC gets it by default. So this is how the library linking works. Hope you guys have understood. Hope you guys are enjoying these classes, and don't forget to subscribe. See you next time.